All right, today's notes 1-2 properties of real numbers. And this is something that this is one of the few lessons that we're going to do in here where it's really a lot of vocab. And so as we get into this today, just pay attention to all the highlighted terms right there because we're going to know what they all mean. I think what would be pretty helpful for you in your notes is to go copy down this chart right here. And so every number that we have, it fits into one of these categories, all right? And so we have the whole thing. This R right here encompasses everything. Those are called real numbers. And then inside of that, we can have rational, which they use or identify as letter Q, and irrational. And then it goes integers, whole numbers, natural numbers. The one thing to understand about these circles, whichever one it is, if it's a natural, then it's whole, it's an integer, it's rational, and it's a real number. If it's just an integer, if it fits this definition, it's an integer, then it's a rational, then it's a real number. So wherever it fits in the circle, it's from there all the way out. If you ever get irrational, that's over here by its own or by itself, it's also a real number, all right? And so they give some pretty good examples here. You can see where decimals hit, where fractions hit that may not clean up and be a nice, neat whole number or anything. You can see where like pi and a square root that doesn't clean up, or this one's radical 3. If you do those in your calculator, you'll see that those can be some long decimals, and they're going to fit into that irrational category. As we get into integers, you can see right here that integers includes positive and negative, all right? Then when we get to whole numbers is just positive, but it also includes 0. And then you can still have something like this, like square root of 36. We know that that answer is 6. So that fits the whole number definition. And then natural numbers have got to be positive and not include 0. So whole numbers and natural numbers are really similar. It's just that 0 fits the definition for a whole number as well. So real simple in the book, example 1, I'm not even going to write this down. It says name the sets of numbers to which each number belongs. Negative 23, then you can come up here and they actually match it up. It's an integer. So since it's an integer, or it fits right here in the Z circle, then it's also rational and it's also a real number. And so they would just put Z, Q, and R. All right, next one down, square root of 50. That doesn't clean up. It's not a perfect square. So since it's a little bit funky and it isn't a perfect square, it's going to fit here in the irrationals, which is this side of the chart. So that's irrational and real. I, comma, R. Then negative 4/9, that doesn't clean up. I mean, if it was negative 9 over 9 and it was just negative 1, you've got to still be able to reduce those. But negative 4 over 9 doesn't reduce, doesn't clean up. So we can find it up here. Those kind of funky fractions are rationals, and then they're reals, Q, comma, R. Not going to spend a ton of time on that, but you need to know that. All right, let's flip and keep going. Next thing that we're not really going to write down, but you need to be aware of, is the properties of real numbers, okay? I'm not going to make you define what these are. You just need to understand what's going on. If you have the commutative property for addition, that means you can switch the order of the way you add things, meaning like 2 plus 4 would equal 4 plus 2, and that's true. It works for multiplication as well. 2 times 4 is the same as 4 times 2. That's called commutative. And those are just some nice terms to have. I would put those in your notes as well. Again, when we test over this stuff, I don't foresee me saying, hey, tell me what the commutative property is. I do see you having to understand how it works. So if you need some examples of that, look at examples 2 and 3. But that's not where I'm going to spend time today. We're going to go ahead and jump all the way down at the bottom of page 13 to example 5. And now we're going to start simplifying expressions. I would say in algebra, that's one of the big things that we've got to be able to do. So I'm jumping right down here, over here on the left side of the screen, example 5. And we're told to simplify this. 3 times 2q plus r plus 5 times 4q minus 7r. And they want us to simplify. Okay, and again, we are in example 5. As we do this, we are going to do PEMDAS. So we've had that lesson. We should be good with it. So that means, hey, look in the parentheses first. When I look in this parenthesis, when I look in this parenthesis, they are not like terms. Q's and R's cannot be added or subtracted because they're not like terms, or they don't have the same last name. So we leave them alone. I don't have any exponents. I do have multiplication. I actually have it twice. Distributive property says I have 3 times this set of parentheses, and then I've got positive 5 times this. We can just go from left to right like we do in our language. So I'm going to take 3 and I'm going to distribute it. I like drawing arrows showing that I'm going to multiply it in there to every term. So 3 times 2q is 6q. 3 times positive r is positive 3r. So that's how that multiplies or distributes. One thing to catch here, I'm going to multiply all of that. So positive 5 times 4q and then negative 7r. It really doesn't matter when it's positive. You would probably multiply that way anyways. But if it's negative, you're going to want to include that sign. So let's just make sure we're doing that every time. All right, here we go. Positive 5 times 4q would be positive 20q. And positive 5 times negative 7r would be negative 35r. If you're not good at positive times negatives, that's okay. Grab a calculator and let it help you. All right, at this step, we've got to see if we've got like terms. I got a bunch of addition and subtraction. So for PEMDAS, we can just kind of do it all. If you want to go from left to right, that's fine. But pay attention to your like terms. So my q's go together. So 6q plus 20q makes 26q. All right? And then my r's go together. I have positive 3r and negative 35r. And I just like grouping them together. I may underline them, I may put a circle around them, I may put a box around them or something to just draw my attention to the fact that those have the same last name or they're common terms. So positive 3r minus 35r is minus 32r. I cannot combine q and r, even though this says subtract. These are not the same last name. The proper etiquette, I would say mathematically, is to put the one that comes in the alphabet first. Q comes before r. We're going to leave it just like that. All right, I'm going to jump down to the bottom right here and do this guided practice number 5. So we're going to keep on. And that one says to simplify. So the difference in simplify and evaluate, a couple lessons ago we saw evaluate. That's where you're plugging in numbers and solving and getting a number answer. Simplify is literally what it says. We're going to simplify and combine like terms. So we're going to simplify 3 times 4x minus 2y, and then minus 2 times 3x plus y. This is what I was talking about with this sign right here, going with the 2 when we distribute in a second. All right, PEMDAS says, hey, check parentheses. I have no like terms, so I can't do anything. There are no exponents in PEMDAS, so let's do it the multiplication. Technically, multiplication and division go together. I've only got multiplication here. Let's go distribute. 3 times both of those, and negative 2 times both of those. Multiply it out. 3 times 4x is 12x. 3 times negative 2y, negative 6y. Again, paying attention. We are distributing the negative here also. That'll take care of addition and subtraction when we multiply. Just trust it. Negative 2 times 3x, negative 6x. Negative 2 times positive y, negative 2y. All right, all subtractions, which is obviously what we're going to have to do in PEMDAS. So let's do like terms. There's my x's. 12x minus 6x is 6x. Look at, I have minus 6y minus 2y. Negative 6 minus 2 is negative 8. And then y is my last name. I can't combine those. They don't have the same last name. So we're done right there. Let me check and see what we got. Yeah, that's it. So pretty simple notes today. Not a ton to take. Make sure, again, that you have gone in, starting on page 11, and that you have copied down this little chart right here. This is a great little deal for you. If you need the words or the definitions to go with that, look at your yellow highlighted terms or go to the glossary. Flip the page. Go ahead and get this table on real number properties in your notes. That's something that's going to come in handy. We're going to continue on in chapter 1 as we're doing this. Thank you for your attention.